The traveling salesman problem that we just discovered together and how to model it with a circuit constraint is an easy one because you've got only one vehicle that need to visit all the cities. The problem is a little bit more complex when you have several vehicles at your disposal to visit all the different cities. And this more general problem, we call it the vehicle routing problem. Okay. Let's take an easy version of the vehicle routing problem, but there are many different types of vehicle routing problems. In one depot, okay? The depot is the starting point in the morning of all the vehicles, and then all the vehicles need to visit at least once every customer here, okay? So you need to visit every customer. And you want to minimize the total distance that is traveled by all the vehicles together, right? And every customer must be visited exactly once. And of course, you are also given an input, a distance matrix. Okay. The problem is that if you look at this solution, this is not exactly a Hamiltonian circuit. Every sub-circuit here, every sub-color circuit is a Hamiltonian circuit, right? But they have one node in common, which is the depot. And so the difficult question is to model this with a circuit constraint. Of course, what you could do is split in advance or partition or cluster the set of customers that you want to visit, and then independently solve every TSP, every sub-TSP. The problem is that the partitioning that you will find in advance may be not the correct one, maybe not the best one. Okay, so we don't want to limit ourselves. We want the problem to discover by itself the partitioning that it will find. And so there is an easy modeling trick to solve that problem with just one circuit constraint that I will just explain now. And this is a modeling trick that consists in decoupling or replicating the depot node as many times as the number of vehicles that you can use. And so in this case, we have three vehicles, We've got three vehicles, so it means that I will replicate artificially the depot 3 times, okay? But every depot that I will replicate, I will give him a color, okay? Which is the starting vehicle, okay? So this one will be the start of the blue one, this one will be the start of the yellow one, and this one will be the start of the red one, okay? And once you have that, okay, you can post only one single circuit constraint because every depot, artificial depot, will now be visited exactly once. Okay, so here, just one circuit constraint. Okay, if you enforce a Hamiltonian circuit on this problem, you've got a problem for your initial problem. So you can solve a kind of TSP for this problem and you are done. Just to tell you a little bit about the more general version that you can find for vehicle routing problems, in practice, we may also enforce a capacity. For instance, we may say that a vehicle can visit at most a given number of vehicles, so it has a limited capacity. Or you could decide that you would collect an amount of material in every city, and the truck has a limited capacity and you cannot exceed this capacity. Another different type of constraint that you may have in vehicle routing problems is time windows. You may say, I want to visit this customer between 10 and 11, okay, and not outside this time window. Okay, so these are all the kind of constraints that you may find in vehicle routing problems. And with this model, of course, you can do it, but you need to introduce additional variables such as the visiting time, such as the current load of the truck. So you can introduce one variable for every city to explicitly model the current load of the truck just when arriving or departing from this specific customer. Okay, so these are the vehicle routing problems, and again, remember this modeling trick of duplicating artificially the number of depots is very useful.